My dear students, today I am going to discuss trigonometry for class 10. Okay. Now let us see the things which occur in the beginning. Now there are 6 trigonometric ratios. All right. So these are the 6 trigonometric ratios. Sine of angle theta, cosine of angle theta. Now this theta is a Greek letter which stands for or which represents an angle. Tangent of angle theta, cotangent of angle theta, secant of angle theta, and then at last cosecant of angle theta. Now this theta is the angle in a right angle triangle. This is a right angle triangle. This is 90 degree. Now this angle, this base angle which is acute. Now in a right angle triangle, one angle is 90 degree and the other two are acute. So this angle is acute and it is represented by this Greek letter theta. Alright. Now in this right angle triangle, so this line is hypotenuse. So already you know these things. The side opposite to the right angle is called hypotenuse, isn't it? Now this side we will call opposite to the angle under consideration. Now this is the angle we are discussing, angle theta. Now opposite to this angle theta, this is the side. So this side will be called opposite. And this side is touching the angle theta. So this will be called adjacent. Now you can call this one perpendicular, this one base, this one hypotenuse. But if you call this way, if you call opposite adjacent, and this is always hypotenuse, then it will be easy to find out these trigonometric ratios, whether the triangle is in this position or suppose there is a triangle in this shape. So here, now this is a hypotenuse. This will be hypotenuse opposite to the right angle. Now if we consider this as theta, if we consider this as angle as theta, then this side will be opposite. So opposite to angle theta, this side. So this side is opposite to angle theta. And this side is touching the angle theta. So this will be adjacent. So now here you cannot say perpendicular, base and all that. So you may have to consider triangles in different positions. Now in this position it is very easy to say this is perpendicular, this is base. But in this position it is difficult to say which is perpendicular, which is base. Therefore we will use these terms if we consider, if we discuss, if this angle is under discussion, then this side will call opposite, this side will call adjacent. So here this angle is under consideration. So this side is opposite, this is adjacent, this is hypotenuse, of course, this is hypotenuse opposite to right angle. Okay. Now sine of angle theta. Now this sine of angle theta is opposite by hypotenuse. Opposite by hypotenuse. So this sine, suppose we call this A, this B, this is C. And suppose we call this one, this is P, this is Q, this is R. Alright. Then sine of angle theta will be this, opposite by hypotenuse. That means AC by AB. AC by AB. And you see this is a ratio. In this way you will see all these will be ratio. So that is why all these are called these 6, 1, 2, 3, 4, 5, 6, these 6 are called trigonometric ratios, and they have no unit. Ratios do not have any unit. Now suppose this is 5 centimeter, this is 8 centimeter, then centimeter will cancel, so it will be 5 by 8 only. It is just a ratio. So sine of angle theta is what? Opposite AC by hypotenuse AB. Now if you consider this, so sine of this angle theta will be what? Opposite PR. So this will be PR. In this triangle, sine of this angle will be opposite by hypotenuse. That means PR by QR. So in this triangle, sine of angle theta, theta is the angle under consideration which is acute. So opposite by hypotenuse, that means AC by AB, AC by AB. And here sine of this angle theta which is under consideration, opposite by hypotenuse, that means PR by QR, PR by QR. All right. Now cosine of angle theta, this cosine of angle theta is which ratio? Adjacent by hypotenuse. So this thing you have to remember, sine is opposite by hypotenuse, cosine is adjacent by hypotenuse. Now adjacent is here BC, CB, so CB by AB, so CB by AB. So in this triangle, cosine of angle theta is what? Adjacent by hypotenuse, that means CB by AB. Now in this triangle, what will be cosine of angle theta? So what by what? So adjacent by hypotenuse, that is what you have to remember. Now in this is adjacent, PQ, PQ by PR, PQ by QR, PQ by QR. PQ is adjacent and hypotenuse QR. I followed? Okay. That will now come to tangent. Now tangent of angle theta. Tangent of the angle theta. So this is equal to what? Let us see which ratio. Now tangent is opposite by adjacent. Opposite by adjacent. All right. Now in this triangle, you can call it perpendicular by base. No problem. But it is opposite by adjacent. So AC by BC. AC by CB. Now in this triangle, what? In this triangle, opposite by adjacent. Opposite by adjacent means PR by PQ. PR by PQ. PR by PQ. So opposite is what? PR. Opposite PR, and adjacent is what? PQ. PR by PQ. I follow? That way, now cotangent. Cotangent of angle theta. So this is which ratio? Now cotangent is what? Now tangent was opposite by adjacent. Cotangent is adjacent by opposite. Adjacent by opposite. That means CB by CA. So CB by CA. So tangent is opposite by adjacent, and cotangent is just reciprocal. That is adjacent by opposite. That means CB by AC. CB by CA. That is AC. And in this triangle, what will be this one? Which ratio? Adjacent by opposite. That means PQ by PR. PQ by PR. PQ by PR. I followed? Now, secant of angle theta. Now, secant of angle theta is which ratio? Hypotenuse by adjacent. Hypotenuse by adjacent. This ratio is called secant. Now, hypotenuse is what? AB. AB by adjacent. Adjacent is CB. Okay. Now in this triangle, it is which ratio? So hypotenuse by adjacent. That means QR by QP. QR by QP. So QR by QP. QR by QP. Okay. So at last remains cosecant. Cosecant of angle theta. Cosecant of angle theta. So cosecant of angle theta is which ratio? Hypotenuse by opposite. Hypotenuse by opposite. That means AB by AC. AB by AC. So AB by AC. AB by AC. And in the other triangle, this is equal to what? In other triangle, hypotenuse by opposite. All right. That means QR by PR. QR by PR. QR by PR. Okay. So you see, this is how we get the 6 trigonometrical ratios have been defined. So cosine of sine of an angle is the ratio of what? Sine of an angle is ratio of opposite to hypotenuse. Cos of an angle is ratio of what? Adjacent to hypotenuse. That tan of an angle is what? Opposite by adjacent. Cotangent is what? Adjacent by opposite. That way 6 trigonometric ratios have been defined. Okay. Now these names, sine, cosine, all that, they have been shortened because these are supposed to be a long term. So therefore they have been defined, they have been shortened like this one. So instead of writing all the way sine of angle theta, we simply write sine theta. We simply write sine theta, and sine theta is written like this. All right. Similarly, cosine of angle theta has been shortened to this, cos theta. Then tangent of angle theta has been shortened to tan theta. Cotangent of angle theta has been shortened to cot theta. Then secant of angle theta has been shortened to sec theta. And then cosecant of angle theta has been shortened to cosec theta. Cosec theta. All right. So sine theta is this, cos theta, tan theta, sec theta, cot theta, sec theta. This is cosec theta. So instead of writing sine of angle theta, we have shortened to sine theta. So this way, for convenience, the terms have been shortened. Right? Now, one mistake students make like this. Now, sine theta, it does not mean, sine theta does not mean sine into theta. It does not mean sine into theta. So this is one common mistake shown by students. So sine of angle theta, that of doesn't mean into. So sine theta, many think it is sine into theta. Those who do not have the concept clearly. So sine theta simply means you have to remember sine of an angle theta, which is a ratio. So it doesn't mean sine into theta. That way tan theta doesn't mean tan into theta. Okay, please do not make this mistake. I have seen from experience many students make this mistake. Okay. All right, now you see the relation among these 6 trigonometric ratios. Now sine theta is AC by AB, and cosec theta, you see, just the reciprocal of this. This is AC by AB, this is AB by AC. So sine theta is AC by AB, cosec theta is AB by AC. So AC by AB and AB by AC, they are reciprocal of each other. If you see the other triangle also, what you see? Sine theta is PR by QR, and cosec theta is QR by PR. So you see PR by QR and QR by PR, they are reciprocal of each other. Therefore, these two are reciprocal of each other. That means sine theta and cosec theta are reciprocal of each other. All right. So this is one relation we get. This is one important relation we get. So what do you get? Sine theta into cosec theta is equal to 1. They are reciprocal of each other. Product of two reciprocal quantities is always 1, isn't it? Say 3 by 2 into 2 by 3 is 1. 3 by 2 and 2 by 3 are reciprocal of each other. All right. So if you multiply two terms which are reciprocal of each other, product will be 1. So these two are reciprocal of each other. So sine theta is cosec theta by 1. So from here you can derive sine theta is 1 by cosec theta and cosec theta is 1 by sine theta. Okay. Now coming to this and this, cos and sec. Now see cos and sec, you will find they are reciprocal of each other. You will find they are reciprocal of each other. How you see? Cos is CB by AB. Here you see cos is CB by AB. And then sec is AB by CB. So you see CB by AB and AB by CB. So they are reciprocal of each other. In other triangle also you see cos is PQ by QR and sec is QR by QP. So PQ by QR and QR by QP. So they are reciprocal of each other. So therefore product of these two will be 1. So that is another second relation we get. So which two are reciprocal of each other? Cos and sec. So cos theta multiplied by sec theta is equal to 1. All right. Then finally you will see these two are reciprocal of each other. So tan and cot. Tan is AC by CB and then cot is CB by AC. See, these two are reciprocal of each other. This is AC by CB, this is CB by AC. Similarly, in the other triangle you see this is PR by PQ, this is PQ by PR. PR by PQ, PQ by PR, reciprocal of each other. So these two are reciprocal of each other. I followed? So which two are reciprocal of each other? Tan and cot. So tan and cot are reciprocal of each other. That means their product is 1. So tan theta into cot theta equal to 1. So tan theta into cot theta equal to 1. Therefore, tan theta is 1 by cot theta and cot theta is 1 by tan theta. So cos theta into sec theta equal to 1. Therefore, sec theta is 1 by cos theta and cos theta is 1 by sec theta. Now, if you know these relations, then in the exam you will find very easy to solve numerical problems. Okay. All right. Now you say one thing. Sin theta divided by cos theta is what? Right? Now in this triangle, sin theta is what? Opposite by hypotenuse. Then AC by AB. AC by AB. That is sin theta divided by cos theta. So in this triangle, what is cos theta? Adjacent by hypotenuse. That means CB by AB. CB by AB. So sin theta divided by cos theta. Sin theta is AC by AB and cos theta is CB by AB. Now when you divide this AB cancel, so what we are left with? AC by CB. AC by CB. Now what is AC by CB? AC by CB. So AC is opposite, CB is adjacent, or you can say this is perpendicular, this is base. So perpendicular by base, or it is opposite by adjacent. Opposite by adjacent, so this is tan theta. So what we got? Sin theta by cos theta equal to tan theta. This is another very important relation. So this relation, this one, now we got this fourth one. Sin by cos. Sin by cos is what? Tan theta. Now what will be cos by sin? Cos theta by sin theta. Now sin theta by cos theta and cos theta by sin theta are reciprocal of each other. Now that means reciprocal of tan. What is reciprocal of tan? Cot. So if you do this way, you will see it is cot theta. So I followed. So tan theta equal to sin theta by cos theta, and then cot theta is cos theta by sin theta. So this way also you see they are reciprocal of each other. So sin by cos and this is cos by sin, they are reciprocal of each other. So tan and cot are reciprocal of each other. All right. So these relations, so here you see 5 really important relations. So as I told you before, if you memorize these relations, it will be very easy to solve numerical problems. Okay. All right. Now we'll see some formula of trigonometry. Now these 3 important formula we have. So firstly, sin square theta plus cos square theta equal to 1. Sin square theta. Now how to get this formula, how to derive, that I'm going to show. But first of all, let us see the important formula. Sin square theta plus cos square theta equal to 1. All right. Now from here, what you get, sin square theta is 1 minus cos square theta. Sin square theta is 1 minus cos square theta. And cos square theta is 1 minus sin square theta. All right. Now this is the main formula. This is the main formula. Now these two are derivations. So sin square theta plus cos square theta equal to 1. Now therefore sin square theta will be 1 minus cos square theta, and cos square theta is 1 minus sin square theta. Now here one very important point, again students make mistake. Let me tell you. What is the meaning of sin square theta? You see, sin theta into sin theta. Sin theta into sin theta is sin theta whole square. It is like x into x. What is x into x? X square. What is a plus b into a plus b? A plus b whole square. So this way sin theta into sin theta is what? Sin theta whole square. Now sin theta whole square has been shortened for convenience in writing sin square theta. So you see the meaning of sin square theta. Sin square theta means sin theta into sin theta, or you can say sin theta whole square. Now what mistake students make is this one. So this they think sin square, sin into theta. I follow. This is one mistake students make because the concept being not clear. So this by mistake they write sin into sin. This is sin square. They think it is sin into theta. So actually this means what? Sin square theta means sin theta whole square, which again means sin theta into sin theta. That a cos square theta means what? Cos square theta means cos theta into cos theta. This cos square theta means not cos into cos. It means cos theta into cos theta. That means cos theta whole square. You follow? Okay, so okay, now coming back to this. So this is the main formula and this is the derivation. Now, if you remember the derivation, then again I say it will be very easy to solve numerical problems in exam. Quickly you can write this one instead of going to the main formula. So sin square plus cos square equal to 1. Therefore sin square will be 1 minus cos square will be 1 minus sin square. Okay. Now the second one is one plus tan square theta equal to sec square theta. Now again tan square theta like before, do not make the mistake. Tan square theta means tan theta into tan theta. Sec square theta means sec theta into sec theta. Okay. Now this is the main formula. And what are the derivations? This is the main formula. And derivations are what? Tan square theta equal to sec square theta minus 1. So if you take 1 to the right side, equation rule. So tan square theta will be sec square theta minus 1. All right, or sec square theta minus tan square theta equal to 1. So this tan square theta you take to the right. So it will become sec square theta minus tan square theta, that is equal to 1. Sec square theta minus tan square theta. So these two are derivations. This is the main formula. So from here we get tan square theta is sec square theta minus 1, and then we get sec square theta minus tan square theta equal to 1. Now this relation is important because you can use a square minus b square formula in exam. For some problems, for some numerical problems, you will have to use this one, that is a square minus b square formula, a plus b into a minus b. This is why these derivations are important. Okay. So from this one we got these two derivations. Then coming to the third one. Now the third formula is this one. 1 plus cot square theta, that is equal to cosec square theta. So 1 plus cot square theta equal to cosec square theta. Again, cot square theta means cot theta into cot theta. Cosec square theta means cosec theta into cosec theta. All right. Now from here, what is the derivation? Cot square theta equal to, this goes to the right, cosec square theta minus 1. Cot square theta is cosec square theta minus 1. And what is the other derivation? Cosec square theta, this goes to the right, minus cot square theta equal to 1. So cot square theta goes to the right. So cosec square theta minus cot square theta. Cosec square theta minus cot square theta equal to 1. So like here you have these two derivations. Similarly here also these two derivations. Then for this derivation you can use the formula a square minus b square formula, a plus b into a minus b. So as I told you, for some numerical problems they will be important, they will be necessary. So cosec square minus 1, then cosec square minus cot square equal to 1. So here you get sec square minus tan square equal to 1, and tan square is x. So these three important formula. Okay. All right. Now see the derivation of the formula. Now whether I am teaching you fast, I am going fast, slow, you please give me feedback. Some of you have given feedback already in my other videos, so you also try to give feedback. I mean, whether I should do more clearly, or I should go faster, I should go slower, like that. Okay. Now let me see. Let me show you the derivation of the formula. The first formula. So consider this right angle triangle. Okay. Suppose we call it ABC. ABC is a right angle triangle. So this is the angle under consideration, theta, which is acute. All right. So this is hypotenuse, this is opposite, this is adjacent, or this is perpendicular, this is base, this is the right angle. All right. Now we are going to derive those three formula: sine square plus cos square equal to 1, 1 plus tan square equal to sec square, and 1 plus cot square equal to cosec square. Okay. Now see how easy it is. Now according to Pythagoras theorem, you see AC square equal to what? AB square plus BC square. So according to Pythagoras theorem, AC square equal to AB square plus BC square. So this is hypotenuse. Let me write, this is adjacent, and this is opposite. So opposite to angle theta, this is hypotenuse, this is adjacent to angle theta, touching angle theta. Okay. Okay. Now this is what we get by using what? Pythagoras theorem. Now let us divide the whole equation by AC square. So dividing the whole equation by AC square, that is hypotenuse square. So divide the whole equation by AC square. All right. So first you write the Pythagoras theorem, AC square equal to AB square plus BC square, then divide the whole equation, that means each term, by AC square. Now what you get, you see AC square by AC square 1. Now this is AB square by AC square is AB by AC whole square, plus this is BC by AC whole square, BC by AC whole square. Alright, so 1 equal to, yes, now see AB by AC, opposite by hypotenuse, that is sine of angle theta, sine theta. So this is sine theta whole square, plus BC by AC, adjacent by hypotenuse, that is cos of angle theta, cos theta. So cos theta whole square. Okay, so we got 1 equal to this. Now we got the answer. Only thing we have to rewrite. So sine theta whole square, I showed you before, it is written as what? Sine square theta. And cos theta whole square, how will you write? Cos square theta. So this is the first formula. Already I showed the formula. So sine square theta plus cos square theta equal to 1. So you can write 1 this side if you want, right? So we remember the formula this way. We remember the formula in this form, sine square theta plus cos square theta equal to 1. Okay. Now this was the first one. Okay. Now let us see the second one, how to derive. So to get this first formula, what we did, we divided each term by AC square. We divided each term by AC square. So first we wrote the Pythagoras theorem, this relation, and then we divided each term by AC square. All right. Okay, now let us see this one. Now next we divide the whole equation by that BC square, that is adjacent square. We divide the whole equation by this adjacent square, that is BC square. Okay. Then see what we get. Now this will be 1, BC square by, so this will cancel, it will be 1. All right. Now AB square by BC square, that means AB by BC whole square. AB by BC whole square, AB by BC whole square. And this side is what whole square? AC by BC whole square, AC by BC whole square. All right. Now AC by BC whole square, what is AC by BC? AC is hypotenuse and BC is adjacent. So hypotenuse by adjacent is sec. So this is sec theta whole square. So sec theta whole square. So AC by BC, hypotenuse by adjacent, that is sec of this angle, sec theta. So sec theta whole square. Now this is what whole square? AB by BC, opposite by adjacent, or you can say perpendicular by base. So that is tan of angle theta, that is tan theta. So you see that Pythagoras theorem equation, if we divide the whole equation, that means each term by BC square, divide by BC square, adjacent square. So what do we get? We get this one. So from here, what is sec square theta equal to sec theta whole square is sec square theta. That is how we write this whole square. So tan square theta plus 1. So this was the second formula. So tan square plus 1 equal to sec square theta. You can remember it, try to remember the formula, I mean direct way or reverse way. You follow? A square plus B square equal to 1. That means 1 equal to A square plus B square. So try to remember each formula both ways, because in the exam for many numerical sums you have to use the formula, not only this, other formula also, one way or another. Okay. So sec square is tan square plus 1, that means tan square plus 1 equal to sec square. Okay. This was the second formula. We got it how? Dividing each term of the equation obtained from Pythagoras theorem by what? Adjacent square. Thirdly, we are going to divide each term by hypotenuse square. Okay. Now let us see the third formula, how we get. What is the third formula? Cosec square equal to cot square plus 1. Let us see how to get that. Okay. So same diagram will do, you see, same diagram will give you all these three results. So according to Pythagoras theorem, what we get? AC square equal to AB square plus BC square, isn't it? Now we are going to divide each term, the whole equation, that means each term by hypotenuse square, that means AC square. Not this time. Oh, yes, we already did by hypotenuse square, then we got the first formula. Our second formula we got by dividing each term by adjacent square. Now we are going to divide each term by opposite square, that means AB square. AB square, AB square, AB square. All right. So we are dividing the whole equation, that means each term by what? AB square. All right. Now this will be 1. So here this will be 1. And this will be what? BC by AB whole square. BC by AB whole square, isn't it? BC by AB whole square. All right. And what will be this one? AC by AB whole square. AC by AB whole square. Is it clear? Okay. Now let us see the next step. So AC by AB whole square. Now what is AC by AB? AC by AB, hypotenuse by opposite. Hypotenuse by opposite is cosec. Cosec of this angle theta, that means cosec theta. So this is what? Cosec theta. Cosec theta whole square equal to 1 plus BC by AB. BC by AB. Now BC by AB is adjacent by opposite, that is cotangent of this angle, that means cot of theta, cot theta. So BC by AB will be cot theta. Cot theta whole square. All right. Then this can be written as, for convenience, we write it cosec theta whole square. Cosec theta whole square. So it will be written as cosec square theta. Cosec square theta. All right. So this is 1 plus cot theta whole square. How will you write it? Cot square theta. So we got this formula. So dividing the whole equation by opposite square, we got this. So cosec square equal to 1 plus cot square. That means 1 plus cot square equal to cosec square. As I told you before, try to remember the formula both ways, from left to right or from right to left. So you see, this derivation is so easy. So you take the right angle triangle, then mark which is hypotenuse, which is opposite, which is adjacent. Then first of all, you must mark the angle theta that you want to consider. Okay. Then first of all, you divide by hypotenuse square, you will get the first formula. Secondly, divide by adjacent square, you will get the second formula. And thirdly, we divide the whole equation of obtained from Pythagoras theorem by AB square, opposite square. So as we did here, we got the third. This is how you can derive the formula very easily. Okay. All right, so today I'll stop here. Then in my next video, I'll show you the application of this formula. So I'll show you several numerical sums where these formula will be applied in different forms. So always do not think you will have to write cosec square equal to 1 plus cot square. So you have to write the derived form which I gave you before. That means you will have to write cot square equal to cosec square minus 1 or cosec square minus cot square equal to 1, like that. So in my next video tomorrow, I'll show you the different application of this formula. Okay. So today I'll close here. So I hope this has been useful to you. Good night.